Dear students, in this video lecture we are going to discuss about the syllabus of the structural analysis. Before going to the syllabus, we should know the vision of Civil Engineering Department of our ACGCET college. So the vision of the Civil Engineering Department is to offer novel and economical solutions for the complex and complicated problems arise in civil engineering industry, and to play a significant role in developing the infrastructure in our country, to provide a creative environment for learners to attain high level of excellence in the civil engineering industry. Vision of Civil Engineering Department. Following the vision of civil engineering departments are to create, disseminate and integrate in-depth knowledge in civil engineering among graduates, and to provide a dynamic learning environment that emphasizes open-ended design, problem-solving skills, teamwork, communication, and the leadership skills, which in turn enables the betterment of human society. Second mission of the department is to produce highly competent civil engineering professionals with innovative thinking, ethical standards. Next, to promote quality education, research and consultancy for industrial and societal needs. Finally, to provide state-of-the-art resources that contributes to the congenial learning environment. Coming to our subject code is 22 CG C51 Structural Analysis 1. Course objective is to give an overview about the structural analysis of indeterminate structure and to know how to calculate interface, to analyze the indeterminate beams using theorem of three moments, slope deflection, moment distribution and matrix methods. So we have structural analysis 2 in 6th semester with advanced methods of analysis. Here we have very basic methods like slope deflection, moment distribution, theorem of three moments, which is very easy to solve. 4th and 5th units consist of somewhat advanced level of matrix method of analysis for further designing the structures. The course outcomes are the CO1, that is analyze the indeterminate beam using classical methods to determine support reactions, shear force and bending moment. CO2 is apply the slope deflection method to analyze continuous beams and simple frames under various loading conditions. Third outcome is evaluate internal forces and statically indeterminate structures with and without joint displacement using moment distribution. Fourth unit is to formulate and solve structural problems using the stiffness matrix method for beams and frames. The fifth course outcome is to develop and apply the flexibility matrix method for analyzing the statically indeterminate structure. So conventionally, we can analyze statically determinate structure using three equilibrium equations already you know well, that is summation of Fx0, Fy0, summation of moment 0. Here structure analysis 1 and 2 deals with the indeterminate beams which we cannot solve with the available equilibrium equations. So we need some other additional compatibility equations or some other methodology to analyze the indeterminate beams. So the syllabus of unit 1 deals with the theorem of three moments. It is one of the methods for analyzing the problem of indeterminate beams, and we can draw the shear force and bending moment diagrams for given beam sections. And also basically we should know to calculate the indeterminacy of the structure, because then only you can decide which method is suitable to analyze the particular structure. So the indeterminacy will have two types, that is static indeterminacy and kinematic indeterminacy. So we will going to learn the formulas to calculate static and kinematic indeterminacies. Next one of the indeterminate structure, very basic indeterminate structure is the Probity cantilever and fixed beam. So we are going to analyze the forces and the moments in the Probity cantilever and fixed beams. So unit 2 is very simple methodology of analysis of indeterminate beams, that is slope deflection method. It deals only with the equations of rotations and moments. So we are going to formulate equations for one particular span, and by using the equilibrium equation, that is summation of moments at the particular joint is equal to 0, and some compatibility equation, that is the deflection or the slope is 0 at a particular joint. By using these conditions, we can easily calculate the unknown moments and slopes. Third unit deals with the moment distribution method. It is also very comfortable to analyze for the calculation because it needs some iteration process. Basically, we assume the moment by using the fixed end moment values. So we have a particular formula for various types of beams, that is fixed beam with fixed end condition with the point load, fixed end condition with the UDL, fixed end condition with the different set of point loads. By using the formula, we will get some value of moment initially. Further, according to the type of joint and types of supports, the moment will be redistributed to the nearest supports or the joints. So we are going to iterate the process until we achieve some equilibrium conditions at a particular joint. So it is also very easy to solve this unit 3. Next one, fourth unit is matrix method. It is somewhat advanced method. It will be like PG level, but you can easily understand by formulating the stiffness matrix method for the basic beam elements. So the question will be asked to formulate stiffness matrix method for beam element or axially loaded element. So we are going to learn about the basic properties of matrix, Rankov matrix, and because we need some matrix calculations in our problem, so you should know the basic prerequisite of mathematics here. So the next one, we are going to formulate the stiffness matrix for truss, beam and frame element. It will be of the theory portion, that is we are going to derive the equation with some theories. And using this stiffness matrix equation, we are going to analyze the given beam section. So unit 4 needs some attention before going to start the problematic analysis. Unit 5 needs very much attention because you will feel like difficult in calculating the moments in the given beam section. So please give more attention to the flexibility method, the derivation of the flexibility method for beams, trusses and frame elements. Further, you can solve the numerical problems. So advanced level, you can refer Devdas Menon book and R.C. Hibbeler book. And basic level, very simple explanation, the Vaidyanathan Perumal will be useful. So the next table explains the PO and CO mapping, which is very essential so that totally 12 POs are available and the program specific outcomes are available in 3 numbers. So the 12 POs are common for all civil engineering branches. So the PO1, PO2, PO3 deals with the solving analysis, complex problem solving, analysis and design. So in this analysis subject, we are completely mapping PO1 and 2 and 3. And further, we will have some discussions, group discussions, seminars. So PO9 explaining the teamwork. So let us have a glance on what are the components of PO1 to 12. PO1 is engineering knowledge, PO2 is about problem analysis, PO3 is design solutions. Even though the design solution is not fully involved in this structural analysis, I am giving 3 mapping because we are calculating the bending moments, which is very essential to design. So final step of design is to finding the bending moment, and according to the bending moment value, we are going to suggest some reinforcement or some steel section, etc. So I am mapping PO1, 2, 3 as 3. So there are 3 levels, 1, 2, 3. I am fully mapping with 3 for all PO1, 2, 3. And PO4 conduct investigations. We are not going to conduct any investigation. PO5, we are not going to use any modern tools like STAD Pro. So we will have separate laboratory classes for modern tool usage. PO6, the engineer and society, it is all like the contract and agreement like process. So we are not involved in this subject. PO7, environmental sustainability, it is not directly linked. Ethics, it is partially linked, but I am not mapped here. PO9, individual and the teamwork. So it is involved with the assignments and seminars and group discussions. PO10, communication, it is involved. PO11, project management and finance is not involved in the subject. PO12, we can map for all the subject. Lifelong learning is very, very important for the subject for further future studies, higher studies, and for your placement also. And PSO1, that is program specific outcome, to prepare the plan layout for any civil engineering structure. So in this subject, we are not going to draw any plan and layout. PSO2 is to analyze and economically design the safe and durable superstructure. So we are fully involved with the analysis. So we can make with 3 values of 3. PSO3, investigate issues pertaining to the water treatment, waste management. So PSO3 is mainly related with the environmental. So we are not mapped here. So I mapped with the PSO2 as 3 and lifelong learning with 1, and the PO9 teamwork as 3 and communication as the value of 2. So we are going to adapt these correlations to convert into overall attainment. So next one, introduction to the structural analysis. So a structure is a system of interconnected members used to support external loads. Basically, a structural design needs the calculation of loads. What are the loads coming over the structure? Dead load, live load. You will all have some introduction about the loading conditions in previous semesters. Gravity load, self-weight, snow load, wind load, earthquake load. There are many more loads. So what are the loads to be accounted in a particular situation for the particular problem? What are the loads to be eliminated for a particular problem? These are the points you have to learn in detail. The structural analysis is the prediction of the response of the structure to the specified external loads. Without structural analysis, a design of a structure can't be done. With the analysis results only, we are going to design a member. So, you people should know, analysis is the process which is to be done before a design. It is not after a design. It is to be done before a design work. Structural analysis is to calculate the response of the structure like slope, deflection, bending moment, shear force, and some second order stresses, radial shear, and radial thrust, normal thrust. So these are the responses we can calculate. Design aspect. Preliminary structural design stage, the structure's potential external load is estimated. Basically, the load should be estimated before going to the design. Next one, the size of the structure's interconnected members are determined based on the estimated loads. There are two processes. We can assume a size of member for the structure and we can check for the stability or load carrying capacity at the last. Or otherwise, we can first estimate the load and the response of the structure through analysis, and with the analysis results, we can design a size of the member. We can choose any one of the methodology. Next one, structural analysis establishes the relationship between the structural members' expected external load. Also, it relates develop the internal stresses and displacements that occur within the member when in service. This is necessary to ensure that the structural members satisfy the safety and the serviceability requirements of the local building code and specification of the area where the structure is located. Here there are two terms used. One is safety, another one is serviceability. We can explain with the load carrying capacity and durability. We can relate the terms of safety and serviceability to the load carrying capacity and the durability. So durability is the matter which relates with the service period of the building. Its life period of the building. Serviceability requirements deals with the life period of the building, where the load carrying capacity will be deals with the maximum load it can sustain for the external conditions. So in the next slide, we are going to see about the definition for a structure. The structure is a system of interconnected members used to support externally. Very simple definition. So next we are going to see some marvelous of civil engineering. There is a wing-shaped National Museum at United Arab Emirates, and baskets type building in USA, and egg type office building in India, and the Earth House in Switzerland. So these are the marvelous and the extraordinary construction ideas of civil engineering. So these are the photographs which I have collected from internet. So the structural analysis, in this figure we can able to understand the different types of loads which can be able, can act on the buildings. Snow load, wind load, live load. The live loads are, we are the live loads. We are moving to place, and some furnitures, some towers erected in the structure. These are all called live loads. Dead loads means the self-weight of the every structural member will be counted as the dead loads. And some point of view like retaining wall and the structure beneath the ground level will be subjected to the soil pressure or otherwise the hydrostatic pressure. So these are the different types of loads acting on a structure. So the types of the structure, there are several types of civil engineering structures including buildings, bridges, towers, arches and cables. The structural member types can be a beam, column, tension member, compression member, frame and trusses. So beams basically a longitudinal member. You can easily identify in the in our houses, in our classrooms. It is a longitudinal member subjected to perpendicular loading. The loads are acting perpendicular to the alignment of the element. The length of the beam is significantly greater than its breadth and depth. The cross section of a beam can be rectangular, circular, triangular or some standard sections such as C channel section, T section, angle section and I section. In case of steel sections, we have such types that is C, T, angle and I. In concrete structure, we will have some rectangular and circular. Normally rectangular. In rectangular beams, the width and depth plays major role. The depth of the beam is very, very important in the design. If you increase the depth of the beam, the load carrying capacity or moment carrying capacity of the beam will be increased. So this is a thumb rule to make a structure more safer or to bring the design for safer condition, we can increase the depth of the section. So beams, so we can see the different types of beams, castled beam in which the web portions are hollow in type, and the longitudinal beams which is supported by the formworks. Here we can see the steel sections, steel beams connected with the columns, with bolt and nuts, some places reverse. In this figure, right side figure, we can see a beam with a larger depth. So, normally a beam member will be reinforced at the bottom and at the top because beam is a bending member. Beam is a bending member, and if it bends, the bottom member is subjected to bending and the top fiber will subjected to compression. So we will normally provide the reinforcement at the bottom and at top. But here in this figure, the reinforcement is provided both horizontally and vertically. So this beam is called deep beam. So deep beam design is completely different from the ordinary beam design. So these are the conventional reinforcement pattern of a beam section. Bottom main reinforcement, top main reinforcement, and stirrups surrounds. So the stirrups are provided to take up the shear force. Normally bending is predominant in beam section, but in some cases the shear is very, very dangerous in beam section because normally the beam is designed for bending. If there is some shear, then there will be a possibility of support cracking. 45-degree crack will occur. We can easily identify in our residential houses, some cracks are traveled 45 degree to the horizontal plane, which is indicating the shear cracks. Next one, column. Column is a vertical member that are subjected to axial compression. The top of the column is loaded, so it will be compressed axially, and it is subjected to buckling. When the load is more, it will buckle. Short column is called as strut or stanchions. Columns can be circular, square, rectangular in their cross section, and they can also be of standard sections. When a single member strength may not be adequate to sustain a given load, built-up columns can be used. Built-up column means an I section is kept inside a concrete column, or within an I section, the concrete can be poured. So both steel and concrete can be built up to have more load carrying capacity. The built-up column is composed of 2 or more standard sections. So it is given in the figure. That is, it is normal reinforcement of column, spiral reinforcement. It is a square column. Here you can see the composite column, that is concrete inside within the steel tube. Here the steel I section is inside within a concrete section. Spiral reinforcement is given here, composite column. Here it is a plan view, top view, it is a elevation. So we can see. So these are the column reinforcement pattern. If it is a circular column, the spiral reinforcement given for the main reinforcement. If it is a rectangular column, we can use stirrups, two-legged, and the surrounding stirrups like the reinforcement for taking up the shape. So these are the types of built-up sections. We can assemble the C section with back-to-back arrangement or like this, or we can use some L section for creating an I-type built-up section. So these are all in our idea. We can create any type of built-up sections, any type of designs to use in our building member. Next one, frame. Frame is a combination of beam and column. Frame composed of vertical and horizontal members. The vertical members are called columns and the horizontal members are called beams. Frames are classified as sway or non-sway. When it is subjected to a horizontal force, it is called sway frame. When it is subjected to, it is not subjected to a horizontal drift, it is called non-sway frame. A sway frame allows a lateral or sideway movement, while a non-sway frame does not allow any movement in the horizontal direction. The lateral movement of the sway frames are accounted for in the analysis because it is very essential when we are going for a high-rise building. The drift is very much essential when it is subjected to a earthquake loading, wind loading like that. Frames can also be classified as rigid or flexible. The joints of the rigid frames are fixed, whereas those of the flexible frames are movable. It can be a roller or it can be a hinge support. So we can easily differentiate load-bearing structure with the brick masonry and the framed structure with the steel columns and beams, and also shear wall. We can identify one of the member. The wall is fully reinforced to take up the earthquake loading, which is called shear wall. Shear wall, it is having separate design methodology. The shear wall is simply a wall which is reinforced in horizontal direction and vertical direction. So these are all some types, views of framed building. A beam member and a column member is connected with the truss, and the assemblage of girder and the column in a frame can be seen in this figure. Next one, this is one of the structural building model which is waiting for the conducting experimental. This building is not the real structure, it is a model constructed or assembled for the research purpose, in which the loading, wind load, earthquake load, horizontal excitation can be applied to analyze the response of the structure. Here we have CSIR Chennai, we have Structural Health Monitoring Center, in which these types of testings are conducted. Next one, truss member. So trusses are structural frameworks composed of straight members connected at the joints. So each member is connected at the joints. In the analysis of trusses, the loads are only applied at the joints. We have to remember well that the loads are only applied at the joints, because in beam member we can apply load at any point within the span of the beam. And also in column we can apply axially, the load can be applied axially, or some eccentricity the load can be applied. But in trusses, the load is only applied at the joints, and the load will be travelled along the axis of the member and further it transferred to the support. So you have to remember the load transferring mechanism of the truss. The members are assumed to be connected to the joints using the frictionless pins. It is otherwise called as hinge. It allows enormous rotation. It is connected only with the frictionless pins. So this is the assemblage of members to form a truss. The top members are subjected to compression and the bottom members are subjected to tension. Here we have some types of trusses, queen post trusses, king post truss, and the members, different members in the truss, that is purlin, battens, roof covering. So we have to include all the weights of these elements to our design. Types of joints, we have rigid and flexible joint. So rigid means fixed support. Flexible means it is hinge support. It allows some rotation. So we know it is a bolted connections in the truss member. For solving this, we need some equilibrium conditions. Before going to this equilibrium conditions, we stop with this, and we will discuss in the next class about the equilibrium conditions and compatibility conditions. Thank you.